So heat bleach results in late 2024 are really exciting for us. What they effectively showed is we'd increased our recoveries up to 79% total rare earth oxides. That's up from about 56% when we're using a tank leach process. And what does that really mean for us? Well, it removes a whole heap of complex and expensive processing steps. So it removes the leach tanks, the thickeners, clay washing, solid liquid separation and filters, and all the power that's associated with it. So that's what the Brazilians are using over, obviously in Brazil. But what we've been able to do is remove those steps now, go straight onto a heap bleach pad, and then effectively the liquor that comes out of the heap bleach pad is fairly well clear. Having a clear liquid then opens the doors for a whole heap of other technology that we hadn't considered originally, and that's including nanofiltration, ion exchange, then the impurity removal steps, and then obviously a final MREC and mixed rare earth hydroxide product. So over the last 9 months, we've had lots of test work done with ANSTO, looking at all the various options around there, and we've been slowly putting out the results as they come to us recently. So nanofiltration is quite simply a set of water filters or water cartridges that allows you to push through and produce two different products. One that's recovering over 80% of the acid, which is huge for us, really lowers the operating costs associated with that. And that acid then gets recycled back to the heap leach pads to be reutilised. But what it also does is it decreases by about 69% the water volume reporting to the impurity removal circuits. So what that does is decreases the sizes of your downstream equipment, decreases your capital cost, and obviously there's a huge operating cost saving. We're sort of looking at a hydrochloric acid usage down from what was about 37.5 kilos or kilograms a tonne down to about 7.5 kilos a tonne. So it's a massive saving for us both in terms of CapEx and OpEx. Ion exchange, very similar to gold processing, where the gold that's in liquid form at the time is put onto the carbon, and then carbon is then eluted back out by removing the gold from the carbon and put it back into solution for electrowinning. In our case, what we use is a resin. The resin collects the rare earths and then effectively rejects a large amount of the iron and aluminium impurities that are there. We then take the resin, wash it back off, all the rare earths back off the resin, and then that further optimizes our two-stage ion impurity removal circuit. So effectively, it's a bit of a pre-step to help simplify the downstream circuit. So what we're doing in impurity removal after the ion exchange is simply increasing the pH slowly up to about a pH of 4 or 4.5. During that process, the majority of the aluminium, the iron, and a lot of the other impurities all precipitate out into a solid, and then it leaves effectively a low impurity solution, which we can then process to a mixed rare earth carbonate or a mixed rare earth hydroxide. Mixed rare earth carbonate and mixed rare earth hydroxide has been one of our main focuses. We've been really wanting to get a high quality, low impurity product going forward. To get that, effectively what we do is we take the solution that I just mentioned before and from the ion exchange and the impurity removal, slowly increase that pH up to about the neutral pH around 7.1 to 7.5. That precipitates out a whole heap of solids out, which we then collect, dry, and then that's what's effectively sold as a MREC or a mixed rare earth hydroxide. In our case, the total rare earth oxide content is really, really high. It's about 56 to 59%, depending on your test there. And anything above 50% is actually really, really good. So what's also impressive is the low impurity content of our products there. Really low aluminium, really low iron and silica as well. And importantly, we've been looking at a few of the other learnings that we've seen from other producers around the world. Uranium and thorium content is less than 0.001%, so virtually not there, which is important for transport and also for obviously downstream processes like you see Linus have had issues with Malaysia, etc. So we just remove that issue from the table effectively. What that then does, it optimizes the payability and also hopefully we'll have no refining penalties associated with that type of product. Finally, we really think that this will be highly attractive to the Asian, European and American markets. So not just limiting ourselves to the Chinese market only. So we're actually producing a high quality, low impurity product that's widely usable around the world. So the rare earth market over the last couple of years has been really depressed, more due to China having a lot of volume coming out in the market, keeping prices depressed, and also not being able to allow other new projects to come to light, both outside of China but around the world. What's been a turning point has been the US government buying a stake in Mountain Pass and guaranteeing an offtake price of about $110 US a kilo for NdPr. So that's a bit of a game changer for the industry. Government stepping in and actually finally trying to get outside sources outside of China to be downstream producers and actually supply the rest of the world as well. What we've seen from that is the price that they're guaranteeing is almost double what it has been and what it has averaged over the last 2 years. And that's now starting to reflect the supply and demand forecast that a lot of the analysts have been putting out there with the higher price forecast moving forward. So that incentive price historically to get a lot of these new projects around has needed to be above $100 a tonne or $100 a kilo for NdPr, which is what we're seeing with the government prices and what we'll probably see the market actually come up to moving forward as well. That then allows other projects in the US, Brazil, Australia to effectively come into production like ourselves. So from a project point of view, we've got one of Australia's largest resources. We've got over 682 million tonnes. We've also got our cornerstone resource being the inside centre resource, which has already got 119 million tonnes at 1,652 parts per million trio. So what that then allows us to do is, with the new test work results, the new market that's forming, is to really get some great tailwinds behind the project, get on with the studies, get on with the ongoing test work at ANSTO. We've now got CPC engineering doing an option study for us that will then inform us on our next steps and our path forward.